Hey folks, I want to give an example to hopefully clarify what it means for a function to be onto. So if you'll recall our definition, a function f from this domain A to this output space B is onto if, in English you would say every element in B is hit by at least one element in A. And you could write that down. But in math notation, you would write if for every element in B, there is some input, little a, in set A, so that, that input gets mapped to this output B. All right. I want to look at two examples. I want to look at this function that takes a real number and spits out another real number. Defined by f of x is equal to x squared. Okay, so you can start thinking if you think that's onto or not. And now I want to look at this other function where I specify the output space to be smaller. I specify the output space to be the set of all real numbers x such that x is non-negative, okay? So that's what I mean by this r with the subscript bigger than or equal to 0. Right? What this means is the set of all real numbers that are non-negative. Okay. So let's look at this space. And let's really just put the same function on it, right? My function f is the squared function. My function g is the squared function. In some sense, f and g are the same function, right? They both take an input and square it. But I've specified different output spaces, okay? One of the output spaces is sort of larger, and that means that f is not going to be onto. But this output space is slightly smaller, and that's going to mean that g will be onto. All right, so let's draw f. If I had to draw f, you would probably draw something like this, where your horizontal axis is your input and your vertical axis is your output. All right. Another great way to draw this, though, is put your input here and put your output here. And then, so this is our input space. This is our output space. And then F tells me how to map from the left to the right, okay? So 0 maps to 0. Let's do this with colors. 0 maps to 0. Where does 1 map? 1 maps to 1 squared, which is 1. Where does -1 map? -1 maps to -1 squared, which is 1. Okay. Where does 2 map? 2 maps up here to 4. And where does -2 map? -2 also maps to 4. So you can see, I could visualize f as like all these arrows. I don't know if that's helpful or not, but you'll see that no negative numbers ever get hit, right? If I choose b to be a negative number, there's never an a such that a squared is equal to a negative number. So because these negative numbers never get hit, that's why f is not onto. Let's write that out. F is not onto since if B is negative, then we never have an input, f of x, which is equal to x squared, that can never be equal to this negative number b. All right. By contrast, when I look at G, I've sort of restricted the output space, right? When I draw this picture of G, maybe I might draw it like this. Here's my input, but my output is only these non-negative numbers. Okay, so I've intentionally left off this bit, right? Because that's not a possible output for G. Okay. The picture still looks like a parabola. Okay. If I drew this picture on the right, G takes the reals and it maps now to the non-negative reals. All right. So in sort of the same folding pattern that I had before, right? 0 maps here, 1 maps here, and -1 maps there. 2 maps to 4, and -2 also maps to 4. So again, this real line on the left gets folded over on itself and stretched out. But now we hit every possible output. We hit every possible non-negative number. Every non-negative number is the square of a real number. So G, by contrast, is onto. So all that to say, when you're discussing whether a function is onto or not, yes, the formula of that function matters, but also the space that you write down here, the name of the space really matters. Because for this example, I had two functions with the same formula, but the first function had a bigger output space and wasn't onto. The second function had a smaller output space and was onto. Questions? Public questions to start. All right, thanks.